Okay, in order to solve number 18, what I need to do is I need to find the area of the hexagon in the middle. In order to do that, I need my apothem. So I'm going to draw a line here to here. And I know if this length is 6, then half of this is 3. So I like to redraw it and have a triangle here so I can label it. So I know my apothem is 5.2 and my bottom length is 3. So I can use Pythagorean theorem, and so I would have 5 squared plus 3 squared equals, I'm going to label this side x, and that would be x squared. When I solve this, I'm going to go ahead and just solve it, and the answer is 6. So this is 6 right here. So in order to find my area of the hexagon, I like to do my SANPA. The number of sides is 6. The apothem is 5.2. The N is 6. And I would have, or the length of each side is 6. So my perimeter is 6 times 6, which is 36, and then I just take 36 times my apothem divided by 2. So 5.2 times 36 divided by 2, and that's 93 and 6/6. So now what I'm going to do is I'm going to find the area of the circle on the side here. So this is my circle, and that is pi r squared, and my r is 6. And I get that 6 from my triangle here. Whoops, go back to my pen. This right here is 6, so I know that that's the radius. So that's where I get this 6 from. So pi r squared, so pi times 36 gives me an answer of 113.1. So now to find the area of just the shaded region right here, I'm going to take the circle minus my area of the hexagon. So I would have 113.1 minus 93.6 for my final step. And when I do that, I get an answer of 19 5/10. So that is the area of the shaded region. Number 19, I need to find the area of the shaded region of this figure. The first one is pretty easy. This is a square, so the area of the square is 64. But I have to find the area of this pentagon. So when I do that, I know I have to find my apothem. And so my first step is to say, well, I need to figure out this angle measure. So I take 360, which is the measure of the whole thing, divided by, there are 5 sides, so 360 divided by 5 equals 72, but I only need half of that because that gives me the measure of this whole thing. But I only need half of it, so I'm going to erase that. And so my angle measure here is right there is 36. So I'm going to redraw this. I'm going to say that's 36. And I know that this measure on the bottom is 8 because this is 8, so this is 8, so this little bit is 4. So I put a 4 there. And I know it's a right triangle. And I'm trying to find this side, which is my apothem here, because I need that. So when I do this, I'm going to use SOHCAHTOA, which I have opposite and I have adjacent. So I'm going to use tangent. Tangent of 36 equals opposite, which is 4 over adjacent. And I'm going to use the fish hook. So I go opposite I go on top here. I start here, multiply, divide. So I'm going to multiply here and divide by that. So I have 4 divided by the tangent of 36. And when I do that, I get 5 and 51 5 and 51/100. So I'm going to put that right here. Now I'm going to set up my SANPA. The number of sides, or the side length, sorry, is 8. My apothem is 5.51. The number of sides is 5. And the perimeter would just be 8 times 5, because there are each side is length of 8, and there are 5 sides, so it's 40. I'm going to put a 40 here for my perimeter. And my area, my apothem, I'm going to take, or the area of this figure, of the pentagon only, I'm going to take my apothem, 5.51, times my perimeter, and divide it by 2. When I do that, I get 110.2. So that's the area of this. So in order to find the area of both figures, I just have to add this plus this. When I do that, I get 174 and 2/10. Okay, moving on to number 20. The area of the parallelogram is 196 square meters. If the height is 12, determine the length of the base. So I'm going to draw a parallelogram, so it helps me out. And the area is 196, and I am just going to write the formula for parallelogram, and that is base times height. So I'm going to put 196 here. If the height is 12, determine the length of the base. So I don't know the base, but I do know the height, so I'm just going to say 12b, because I don't know the base. Divide by 12 on both sides, and that will give me the base, which is 16 and 33/100. The area of a rhombus, so I'm going to stop right there and I'm going to draw a rhombus. I know that a rhombus has 4 congruent sides, and I know the area formula for a rhombus is D1 times D2 divided by 2. Some of you may know it as 1/2 D1 times D2. I like to put the 2 on the bottom. So I'm going to fill in my formula. 98 equals, one diagonal is 8, so I'm going to fill in one diagonal, and I'm going to put D for the other diagonal, divided by 2. And when I solve this, I can say 98 equals, I'm going to reduce that to 4D, divide by 4 to get D alone. So D equals 98 divided by 4, which is 24 and 5/10. The area of the trapezoid is 100 square inches, so I draw a trapezoid. I can label the sides then. The area is 100, so I'm going to go over here and I'm going to say area of a trapezoid is height times base 1 plus base 2 divided by 2. Again, you might have half the height times base 1 plus base 2, depending on what your teacher taught you or what you remember. So we have 100 equals, one base is 12, height is 4, so I'm going to put 4 here, 12 here for one of the bases, plus the other base divided by 2. I like to reduce, so I'm going to reduce those. So I have 100 equals 2 times 12 plus b. I'll move this up so we can see it better. And this 2 is multiplied to this, so I can get rid of it by dividing both sides by 2. We're going to minus 12 on both sides to get b alone, so b equals 38.